differential PSK. It is a extension of binary PSK. Differential means differentially encoded PSK. That means the input signal will be differentially encoded before giving it to the PSK demodulator. Now why you are doing so? We have already seen that for binary PSK, the detection is must be synchronous in nature. So we cannot detect binary PSK in asynchronous fashion. To get rid of this problem, we use this differential encoding scheme. Here the digital information content of the binary data is encoded in terms of signal transition. For example, symbol 0 may be used to represent a transition in a given binary sequence with respect to the previous encoded means. That means whenever there is some change from logic 1 to logic 0 or logic 0 to logic 1, we have a transition, and that will be represented by symbol 0, and symbol 1 for no transition. So this may be our logic. So with this we can with this encoding technique along with the PSK is the differential phase shift keying. So the scheme will be like this. We have the binary data, we have encoder, the output is say D, so we need a delay of 1 bit time. It is D k minus 1, and that will be given to the encoder. So encoder has got two inputs, one is the current bit, another is the previous bit, and the output is D, that is given to the product modulator. And corresponding DPSK output is AC cos omega ct, depending on this D is logic 1 or logic 0. So this is the transmitter side or DPSK generator side. For detection, we use a circuit or block like this. This is the DPSK signal, incoming DPSK signal, that is first multiplied with the previous one. Next we have an integrator whose output is L, and we have a comparator. Comparator will compare with some threshold voltage, and based on that we have symbol 1 if L greater than 0. Obviously threshold voltage may be 0, and symbol 0 if L less than 0. To understand this, how it works, let us take an example of a string of bits, like say 0 0 1 0 0 1 0 0 1 1. We will try to modulate it with this scheme, and we will try to demodulate it with this scheme, and we will try to understand whether we can receive the original bit stream back or not. So first consider this table. Binary data given as 0 0 1 0 0 1 0 0 1 1 0 0 1 0 0 1 0 0 1 1. So this is our given data. This is the binary data. Now we have to determine this differentially encoded data, and for that, as you can see, we need previous data. So for the first bit, we assume a bit 1 as if it is a previous bit. It was a previous bit. So previous bit is 1, this bit is 0, so there is a transition, and transition is represented by logic 0. Transition symbol 0 is represents if there is any transition, so it will be 0. So now if B is 0, previous bit, current bit is 0, so there is no transition, that will be represented by 1. No transition means 1. This is our logic. Here 1 and 1, so no transition. 1 1 0, so there is a transition. 0 0 0, no transition, that means 1 1 1, no transition. 1 1 0, transition. 0 0 0, no transition. 1 1 1, no transition. 1 and 1 1, no transition. 1. So this is D. That D is given to the product modulator. So product modulator will generate corresponding phase. So we are more interested on the phase. So phase of DPSK, and that is done with that phase is controlled by the PSK modulator, and for PSK modulator, logic 1 0 phase, and logic 0 means pi phase, conventional method. So 1 will be represented by 0 phase, 0 will be represented by pi. So in this way, we can write the phase of DPSK. So now at the receiver, we have a shifted version of DPSK, 1 bit shifted. So shifted version, that means DK minus 1. So this will be 1 bit shifted actually. So here we have 1 0 1 1 0 1 1 0 1 1. So corresponding phase that will be also shifted by 1 bit. So we have 0 pi 0 0 pi 0 0 pi 0 0. Now the phase comparison output, it is L, phase comparison output. So it will compare the phase between these two, this one and this one. So here we have some change in phase, so that will produce a negative voltage. Here we also have some change in phase, pi phase change, negative voltage. 0 phase change, positive. Pi phase change, negative. Pi phase change, negative. 0 phase change, positive. Pi phase change, negative. Pi phase change, negative. 0 phase change, positive. 0 phase change, positive. So this is the phase comparison output. And phase comparison output is compared with the threshold voltage, and symbol 1 if L is greater than 0, symbol 0 if L is less than 0. So the detected binary sequence, so this one negative voltage, so 0, negative 0, positive means 1, negative means 0, negative means 0, 1, 0, 0, 1, 1. So this is the received bits at the receiver, and these received bits are same as the transmitted binary sequence. So this is how it works. Here you can see that this transmitter is asynchronous in nature because there is no locally generated carrier. There is no question of phase synchronization. So the problem of synchronous detection of conventional binary PSK is now gone. So if we use the differential encoding technique, we can eliminate the need for phase synchronization of the carrier. So this DPSK can be detected in non-synchronous fashion. So that will reduce the cost of the binary PSK receiver system.